range of solutions using a variety of advanced tools through our offices in Chicago, Minneapolis, Raleigh, and Bangalore, India. Our offerings fall into 3 practice areas: application development solutions. These include custom app development, mobile app development, e-commerce, portals, and web design. Business intelligence solutions, which includes end-to-end BI solutions, databases, dashboards, reporting and analytics, mobility, and other advanced BI capabilities. And finally, packaged solutions, and these include software services offerings for specific vertical markets or unique needs. Also, we do offer training solutions that include classroom, virtual, on-site, and custom training programs. Our clients, some of which are listed here today, include some of the most popular names in American business, many mid-market companies, as well as a large number of government agencies and nonprofits. You can see a sampling of those here. To offer our clients the most advanced technology and solutions possible, we maintain close partnerships with industry-leading companies, including Microsoft, IBM, and SAP Business Objects. Okay, and at this point I'm going to turn it over to Jose, today's presenter. I again invite you to submit your questions via the question box on your toolbar, and I hope you enjoy today's presentation. Thank you.
Good afternoon, everyone. This is Jose Hernandez. Before we get started today, in observance of the tragedy that occurred in Boston yesterday, I would like to observe 26 seconds of silence. All right, let's get started. So in the past series that we've done here, we've looked at a variety of topics around data warehousing, and we've always taken a high-level view. This is an introductory series to get people on board with some of the concepts and terminologies around data warehousing. So one of the assumptions that we make is we're assuming that you're relatively new to data warehousing, though some of you, I understand, are not. But you can always pick up a few things and at least get inspired with some topics that you can go further to some of your own research. I do want to keep it fundamental, though following this whole series of basic things, I do want to start getting into some more technical and serious topics, but for the moment this series is more fundamental in nature. We do take a Kimball point of view in these seminars and discussions. And we try to talk about the what, whys, and hows of the various topics that we're looking at here. All right, so before we get started and dive in, let's take a look at the agenda. It's a very straightforward agenda today. We're going to do a quick review of the various parts and pieces that we've talked about up until this point. They are fundamental to why you even need an ETL process. So for some of you who have not attended some of the other webinars, this will be the high-speed version of those webinars. Obviously not in as much detail. And for those of you who have, it's a nice refresher to kind of catch up and remind us of what we've talked about and where we've left off. And obviously after that, we'll start talking about the ETL process. So I consistently put up this slide, and I will continue to do so in all my presentations because it's a very good description of what a data warehouse is. And we don't talk about technologies and techniques and so on, but we talk about the whole purpose and what this thing is and why we're building them. So the data warehouse is a system that extracts, cleans, and conforms data and delivers it in a dimensional data store that supports querying and analysis so that people can make decisions, business decisions. Fundamentally, it's a place where our users go to get their data. Now, that was my not verbatim description. You can see Ralph's quote, which is pretty much in line with that. And so I'd like to also review some of the points of, the goals of the data warehouse, and we look at it from the point of view of the business. And the goals of the warehouse are to make an organization's data easy to access provide a central place so that the business can go and ask business questions and potentially get answers that inspire them to ask more questions that they didn't realize that they needed to know. The data warehouse has to be adaptive and resilient to change. Businesses change all the time, and whatever system that you build has to be built in such a way that you can keep up with the business. And following dimensional modeling and some of the tenets of the Kimball Group, you can ensure that you're in the best position to do so. The data in the data warehouse has to be trusted and secure. Basically, it's your one version of the truth for the organization. And when folks go there and they grab that data, if they compare it to what's going on in their source systems or to what they believe is happening, they have to trust that information. So it's very important that once we build this thing, this data warehouse, that we keep it maintained. And it's much like, and an analogy I've used in the past, it's much like a garden. So initially, you're going to cultivate your soil and you're going to get the garden bed ready and you're going to start planting some seed that'll bear some fruit. And obviously, you need to keep that garden weeded, and you have to turn the soil and maintain the soil and so on so that it'll keep bearing fruit. And if you don't, it'll get full of weeds, and when it's a garden full of weeds, you're not going to bear as many fruit, and you're not going to service the folks that are depending on you for those fruits. Data warehouse is much the same way. After we build it, we have to maintain it. We have to make sure that it continues to flourish. And it's much better to maintain and keep an environment flourishing that is built in an appropriate way and easy to maintain. All right, so when we talk about data warehousing, there's a variety of components that make up the data warehouse, and now is what we refer to as the BI stack. And it goes all the way from your source systems through your BI applications and everything in between. We've been focusing in these discussions, or this particular series, on all the backroom activities, and we're going to continue to do so. In this particular presentation, we're going to focus on the ETL system and basically the plumbing that gets data from your source systems into your data marts that are exposed to your BI tools and your business users. And part of that backroom is also some metadata components, infrastructure, and security. And we're going to touch upon some of that today and discuss a variety of topics. Many of you have already been part of a data warehouse project. Some of you maybe have not and are maybe considering embarking on your first data warehouse project. But of all the components that we talked about, whether it's the BI tools and presenting ad hoc capability and dashboarding and analytics to your users, probably where most of the effort in any data warehouse initiative is in the ETL. And just as a rule of thumb, it's 70% or more of the work involved in building this thing, which is interesting because the part that the users see is the front-end piece, the querying and analysis capabilities and so on. And what they don't see is all the plumbing, all the work that goes to making sure that the BI tools actually function. And it's important that we note when we jump onto this bandwagon on this building this data warehouse that a ton of the work is under the covers and will not be appreciated, but will certainly cause you some pain if it doesn't work. And it's much like, and excuse me for digressing for a minute, but it's much along the lines of one of my favorite shows on TV now. It's Love It or List It, where basically a team goes in and rehabs the house to try to convince the owners of the home to stay in the house as opposed to list the house and move somewhere else. And there's always a certain budget associated with transforming this home so that they would love it and stay there. And oftentimes they uncover infrastructure and foundational types of problems that suck up all the time and all the money. And when you're done, you're left with a house that looks pretty much the same, but it's safe. And I want you to be aware that the same thing is true in these data warehouse projects. A ton of the effort, but unlike the show I just said, you're going to know up front because I'm telling you, a ton of the effort goes into preparing that underlying infrastructure and those databases and so on. So going into it, we know where that's where the effort is going to be, so we won't be blindsided by such an activity. All right, here's where we're going to do a quick review of the various topics that we've talked to up until this point. Pardon me. Starting with dimensional modeling. And we talked, when we had the presentations before, we talked about star schemas, dimensions, slowly changing dimensions, and fact tables, and so on. So let's get a quick review of these components, because after all, the reason we're writing all this ETL is to populate this target database that will be presented to the business users. Okay. Dimensional modeling is basically a technique that allows us to model data in such a way that it's prepared and ready for us to consume it so that we can ask questions. It's different from third normal form modeling, which you would use in transactional systems. Third normal form is great for inserting, updating, and deleting, but not necessarily so good when you want to do selects and aggregate data and figure out trends and so on in this data. Yes, it can be done, but there's all types of issues with the data complexity and performance because of the way that the data is structured. The select statements that you build on third normal form databases tend to be horrific in nature in terms of complexity, and thus a complex SQL statement usually results in a poorly performing result set. So what we do in dimensional modeling is we make sure that the data is stored and designed in such a way that it's easy to ask those questions. The select statements are relatively straightforward. So the steps in dimensional modeling are to identify the business process that we are trying to model, and that basically is the root of a fact table. So what am I measuring? And when I'm measuring this thing, what are the metrics that I care about as I'm measuring? And so that's the first thing. So I'm identifying maybe it's the sales process, maybe it's order fulfillment, whatever that process is. We need to identify that and also identify the grain or the level of detail that we're going to store. As we've mentioned in the past, data warehousing is not about storing aggregated data. It's about storing the most atomic data that you have access to. In your data warehouse, you better have the lowest granularity of data possible, because your business users are going to want to drill into the lowest grain of data possible. So make sure that you are grabbing what you have as much as you can. You need to identify the dimension, the dimensionalities or the dimension entities that you will that will make up your star, as well as identifying the fact tables which are made up of those metrics. And finally, you go ahead and you design and build that star to support the measuring of that business process. So we talk about fact tables and dimension tables and stars. Well, here it is, and we always say, hey, why does it look like a star? Because it kind of looks like a star. Well, I guess if you lay it out this way, it might look like a star. It doesn't necessarily have to, but the idea is that you have a fact table surrounded by dimension tables, and they are joined by a foreign key relationship. So each dimension has a non-meaning, a surrogate key that has no meaning that we use as the relationship between the facts and the dimensions. So the dimensionality is, if you think about it, it's the knives that you would use to slice up the facts that you are recording. And your facts are made up of your metrics. And we'll see in a second here that there's different types of fact tables that we might want to build depending on the business process that we are modeling. Very important and also critical to the ETL function is the concept of slowly changing dimensions. Slowly changing dimensions is a technique used to record history, and there are three basic types of slowly changing dimensions. There is the type 1 where we don't preserve history at all. In fact, we just overwrite the data. There is a type 2 that allows us to preserve all history, so we identify what attributes of a dimension are interesting to us that we want to record history, and then every time those change, we go ahead and record an additional row for that dimension. There's also type 3, which is a point in time or history kind of preservation. It's not very common, but one great example is you might keep a person's last name and their maiden name. So they may get married, and so they change your last name. It's not an event that happens often, but in a point in time. And so you will add a column to store the maiden name and a column to store the current last name. And here we go. We talked about fact tables and different types of fact tables. Depending on what it is that you are trying to measure and the way that you're measuring it, you might use a transactional grain, periodic snapshot grain, or accumulating snapshot grain fact table. Transaction grain is basically recording every point in time, every transaction that occurs, and oftentimes that is appropriate when your measurement, the business process that you're measuring is transaction-based. There's also a periodic snapshot grain type of fact table. So if you think about things like month-end or quarter-end type of measurements that you're taking for a business process, that would be a periodic snapshot grain. And the accumulating snapshot grain, very cool little concept, basically says I am going to record the life of a particular business process in one row. And so the order fulfillment process, for example, starts out with an order being placed and ends up with the order being delivered with a variety of milestones in between. And so each row in that fact table represents that lifespan of that particular transaction. All right. I'm going to take a drink, excuse me. Pardon me. So now let's get back to our focus today. And what we're going to talk about now is the backroom activity around the ETL system. All right. So when I started putting this presentation together, I was going nuts thinking about, look at all these cool things that we're going to talk about. And it didn't take too long before I realized that the whole ETL concept, or that whole discussion, is huge. And there's no way that I can cover the kind of material that's available in 50 minutes. So obviously, what does that mean? That means that I'm going to divide this up into several chapters of talking about ETL. Today's chapter is going to focus on the ETL process, and we're going to talk about some definitions and some basics, so that once you're aware of those basics, we can then start exploring and diving into some of the detailed topics underneath. And you'll see what those are in a bit. And there's a lot of moving parts. There's a lot of concerns and challenges involved in the ETL process. And so I wanted to try to touch upon what those things are. By the way, DeForest Kelly is my new co-host that's going to join me in the presentations, at least this time around. So a couple of definitions that we're right off the bat that we're going to start with. ETL. If you've been waiting this long to figure out what ETL stands for, well, here it is. It's extract, transform, and load. But I'm pretty sure that you all knew that that's what that definition meant. Also want to talk about data warehouse and in conjunction data marts, because oftentimes people are asking me, what's a data warehouse and what's a data mart, and what's the difference between these things? So basically, and this is a good definition, a definition that I like, and you will find many definitions of what a data warehouse is. This is pretty much in line with what Kimball says. It's a collective, basically a collection of things that contain ETL processes, staging tables, conform dimensions, and conform facts. So this whole system of schemas and databases that hold all of your information is the data warehouse. And it's defined in a particular way. We talked about here, it conforms facts and conform dimensions and so on. So if that's the case, well, then what is a data mart? A data mart is basically a specific business process that you are potentially recording, and it's a collection of dimensions and facts that focus on that business process. Sometimes you'll hear people say that a data mart is for a specific subject area. Yeah, kind of. But really, I want you to think of it as a data mart is a business process that you're measuring. It may or may not be a subject area. In fact, you may have several data marts that are related to a subject area and not just the business process. So that being said, a data warehouse could be defined as a collection of data marts, right, with conform dimensions and conform facts, and the other tables required and processes required to support it. So there's another term that's often used. It's the ODS, the Operational Data Store. Traditionally, the Operational Data Store has been a database designed to allow applications to talk to each other, in a sense, It's basically used as a mechanism for integrating data from disparate systems that are transactional in nature. And typically, it can be used sometimes for folks to query against, very special folks to query against, to find out the related data between transactional systems. Today, the operational data store, one could argue, has been absorbed by the data warehouse, and many of the capabilities that were once part of the ODS are stored and capable within the data warehouse. We also talk about staging areas, and basically staging areas is a place where cleansed and conformed data is housed for the purpose of loading into the presentation layer or the stars. And you'll see a variety of definitions for a staging area. These are the definitions that I like, that I go with. You can feel free to adopt them and or tweak them as you will, but be very careful about tweaking them yourself. Do a little bit of research and reading first, and get a variety of opinions from thought leaders within the industry before you come up with your own definition of what one of these things might be. This is a good place to start. All right, so the first thing I'm going to do is mess with you. I'm going to tell you that ETL shouldn't be called ETL, it should be called ECCL. And it's a good idea, but I couldn't quite get the industry to change that acronym. It's 4 letters. We all know that acronyms are supposed to be 3 letters. So, all right, fine, we'll stick with ETL. And let me tell you what the CC are in ECCL. They are part of the T in ETL. Basically, they are the cleaning portion of transformations and the conforming portion of transformations. And so if we look at this basic diagram of an ETL process, we see source systems at the left side and BI tools at the right side, and here's the stuff that's happening in between. I do my extraction, which is the E component of ETL, which then I do some cleansing of that data, I do some conforming of that data, and then I can load it up into my BI tools. What happens is that transformation and extraction activity happens in my staging area, and my loading happens in my start. So logically, think of it this way. There are certain activities that happen in each one of these. They share a common set of tables, potentially, and then we move all the prepared data into our stars. There's another neat analogy that one can use. If you think about a restaurant prepares meals and serves them to the customers waiting at the tables. And if we think about everything that's happening in the transformation, it's the things that are going on in the kitchen. And if you think about that food preparation, you as the customer aren't allowed to go in the kitchen and mess around with what's going on back there, much like you're not supposed to mess around with the staging areas in the data warehouse. In fact, you've got to wait for the data to be, the meal to be delivered to you. And so all that activity happening in the kitchen is protected from you, but when that plate of food is ready, when the meal is prepared, it gets delivered to you at your table. And so consider the star your plate, where your meal is being delivered, and all the stuff that happens in preparation is that staging area that's happening in the kitchen. That's the last of my bad analogies, but I thought it's one that works out really well. In order to develop this ETL process, we need an ETL development team. And the ETL development team should take their job very seriously, and there is a mission statement to the ETL development team. And that mission statement includes 3 main facets. We are going to deliver data effectively to end user tools or end users themselves. We are going to add value to the data by cleansing and conforming that data, and we are going to protect document lineage so that, protect and document lineage so that people know where that data came from, and we can provide evidence of where that data came from and that it was treated with respect. So some of the tasks that we do in the back room in order to do that is the extraction of data from the various data sources, the cleaning of the data and verifying the quality of that data, the conforming of the data to make sure that it conforms to the business rules and tenets that have been established, and then finally delivering that data to physical tables. This is the job of the ETL team. It certainly is a full-time job, and it's a very important job. And the ETL team can be comprised of 1 or more folks or even part-time folks. It depends on the size of your implementation. But regardless of how big or small that ETL team is, These are the various tasks that they are supposed to perform and the various goals or promises that they are making to the rest of the business community. All right, so here's my ETL architecture diagram. If you all have any kind of papers that you have to put together and present as to, here's my ETL architecture, please give me funding. By all means, feel free to steal this diagram and use it for your own. It's relatively straightforward. So the ETL architecture, and this starts getting a little more physical in nature. We talk about our source systems that we have on the left-hand side and our presentation tools that we have on the right-hand side. We're not going to focus on the presentation tools and the front room activities, but we're going to talk about mostly what's going on in the back room activities. Now, there is a little deviation between what Kimball says and the way that I've diagrammed this here. And it's because I decided to take some artistic liberty with the way that I'm presenting this information. And basically, Kimball says that the backroom activity doesn't necessarily include the dimension tables that are ready for consumption. Those are part of the front room activities. I think that it's a little bleed over in that area, just my opinion. And not going to make or break the definition, but that's the way that I like to diagram this thing, because you are loading data into this information. Now, I completely understand that they're part of the front room activity because they are where the users or the BI tools interface with the data that we've prepared. So I completely get that. So let's talk about what's going on here. There's the ETL process is a process, and so there is some extraction, cleansing, and conforming and loading that's going on here. Well, there's a typo in my diagram. Did anyone catch it? That should be an L at the end over there, ECCL, not ECCT. I caught myself. But basically, these processes are taking data and extracting from these source systems and loading them up and doing this cleansing and conforming in our staging areas and finally loading them into those stars. So this diagram kind of tells the whole story of the various parts and pieces. So in your ETL projects, you've got to make sure that you've got some staging areas and databases, as well as your star schemas. So we don't drag data directly from our sources and dump them into our star. We stage them up, we clean them up, we conform them, then we load them up. And we'll talk more about that in a bit. When we also talk about the ETL process, you might have a picture of this linear process in your mind, much like the picture that's over here, where we extract data, then we transform it, and we load it. And so to explain the ETL process, you'll often see these circles or boxes listed and with arrows exactly this way. But it's a little more complicated than that and a little more involved. It's just easier to explain as a linear process. But be aware that the ETL process involves a variety of activities going on at the same time, even waiting for each other for one thing to start and one thing to end, or maybe concurrently doing things. So the diagram really looks a little more like the one at the bottom of the screen, where there's many extraction jobs potentially going on. Some are extracting from various sources, others from completely different sources, and a bunch of cleansing and conforming activities that are going on. Some of the things rely on a sequential series of steps, and some can happen concurrently. So even this is a simple diagram for an ETL process, but I want you to remember that that simple ETL, E to T to L, is a little more involved in real life than just that ETL. Fundamentally, you can see logically that there is a sequence of steps. You extract before you transform, before you load, but there's a lot of little sub-processes going on. All right, so let's talk about the extracting part. And so what's going on in the extracting part? This is where we're reading source data models. And basically, data might be stored in a variety of different structures and a variety of different source systems, whether it be VSAM files or relational databases modeled in particular different ways. In the extracting process, we need to connect and access the data. We're scheduling the source systems for the extractions. We're capturing change data. Part of the ETL process is to make sure that sometimes make sure that I only grab the data that has changed since the last time I went and visited that source system. And then ultimately, I'm staging that extracted data. So I went, found it, grabbed the data that I'm looking for, staged it up in my data warehouse. So it's sitting there waiting for the next step or something to happen. And that next step is made up of two components. So the transform is made up of the cleanse and conforming. So let's talk about cleanse for a minute. And so in the cleansing stages, what we're doing here is we're enforcing column properties, we're enforcing structure, data and value rules. Things like the number can't be less than 0 and can't be more than 30. That's kind of like value rules. We're enforcing complex business rules. And you know, I'm at a loss right now for a complex business rule. I gave you a data cleansing rule. Maybe I'll come up with one before I'm done with the presentation. We're building metadata about the data quality. Very important piece of the ETL process. As you're doing all this stuff, as you're grabbing data, as you're processing this data, you want to start keeping track of when did I go after it, how many rows did I get, did I find any outliers. These are part of the things that you want to do in the process so that you can record anomalies that may have occurred as you're doing the ETL process. And finally, after you've cleaned it up and you've applied all these cleansing rules, you stage the clean data to disk. So now you have data that was extracted, staged. From that staged area, I cleansed it, and now it's sitting there waiting for the next step after cleansing, and that's conforming. And so what I may do here in that conforming process is do things like make sure that my business labels are consistent, make sure that I'm conforming the various metrics and performance indicators that I'm worried about. I could be deduplicating data, maybe because I'm grabbing customer information from 3 or 4 different systems. Turns out that I grabbed the same customer 3 or 4 times. I may want to dedupe it. I don't want to have the same customer in my system 3 or 4 times. There's only really one customer just being represented 3 or 4 times. I may be doing householding, where basically I want to identify that, hey, all these people live in the same household. There's a variety of reasons for why I want to do that. If you think about marketing, I don't want to send marketing material, 5 different pieces of literature necessarily to the same house because 5 different people live there. Maybe 1 is enough. So these are things that I may want to know. Internationalization. If you're an international organization, here's where you may want to do things with translation or maybe currency values and so on. And finally, when I've done all my transformations, I basically take that conform data and I stage it for the purpose of getting ready to load it into my stars. And now here's where we have all kinds of fun. And the loading process, why does it get its own letter in the ETL process if you're just loading the stars? There's all kinds of stuff that's going on here. As you can see, it's the biggest of all the lists. And in the loading process, what we're doing here is we're generating date and time dimensions. We're loading up degenerate dimension attributes inside of the fact tables. We're dealing with our slowly changing dimensions. Here's where, oh, look, there's a change in my customer row. I'm going to add a new row, and I'm going to set the expiration dates and the flags and so on. So there's all kinds of activities going on there. I'm going to deal with late arriving dimensions and late arriving facts. I'm going to deal with multi-value dimension facts and ragged hierarchies and so on. There's a variety of challenges that I'm dealing with in the loading process. By the way, several of these bullet points can be their own presentation. And in suggested reading, as I told you in the past, there's the Data Warehouse Toolkit. And I'm going to introduce you to the Data Warehouse ETL Toolkit as well here, which is where much of this information came from. We're loading up the various types of fact tables, whether it be the transactional or the accumulating snapshot, different kinds of fact tables that we're loading up. And finally, what's happening here in the loading is that we've staged this data into our final schema or structure, the star that is going to be presented to the BI tools and to the users. Remember I said early on that this work, 70% of the work of a BI project is in the ETL. You're kind of getting a sense for why that is the case here. And we've only really touched upon the process of taking data from the source system and moving it into the target star schema. There's a variety of other topics that we still need to at least touch upon. So when you develop this ETL process, there's 2 types of ETL processes that you may want to run. You may do what's called an incremental load or an initial load. They're both ETL processes, but they have a slightly different purpose. let's start with the incremental load. I think that's what people are mostly familiar with. So the incremental load is basically a job that you run or an ETL process that you run at a regular interval. And that regular interval could be nightly, could be weekly, monthly. In fact, you can have some jobs that run nightly, some jobs that run monthly. And the idea here is that I'm looking for changes in my source systems that I want to introduce into my data warehouse. And so in an incremental load, you're processing a subset of the data. Now, when you're loading up your data warehouse for the first time, and you want to load it up with historical data as of a certain point in time, you'll do what's called an initial load. It's a little bit different than the incremental load because I'm not looking for changes in the data. I'm, for the most part, getting whatever's there, and I'm loading it up for the first time. Some folks call it like the historical bulk load, but remember, it is the initial point in time version of that data when the data warehouse is born. Okay. Now, there's a neat little trick that you can do. Let's say that for you're starting up your data warehouse, and you could do an initial load of that data, but you happen to have in your possession snapshots of some of your systems over time. You could go ahead and do an initial load into your data warehouse and record that changing of history for data in history. Because what you basically do is an initial load that loops through and runs an incremental load and using day, for example, as an increment. So pretend it's day 1, pretend it's day 2, pretend it's day 3. And since you have snapshots of your data historically in some kind of backup that you may have, you can certainly do a historical initial load, which is a combination of both incremental load and initial load. So a neat little trick, something that you can do. One other concept that we need to talk about is change data capture. And change data capture basically is about determining what data has changed in my source systems. And there's a variety of techniques that you have to be aware of because when you're building a data warehouse, you never know what source system you're going to potentially come across. There may be some very old systems that, guess what, they just overwrote data within that system. And in fact, you don't even have the source code anymore and you can't touch it. So, gosh, it's still an active system. I can't touch the source code. It's just overwriting data. How can I possibly know what data changes from day to day? That's a scenario or a challenge that needs to be resolved. Or you may have a system that records every time something changes, it records dates, timestamps for every change that occurs. Now, that would be really neat because it'll be very easy to tell what data has changed. So change data capture is basically a set of software design patterns that we use to detect changes. And there's a variety of ways that we can do this depending on the situation. Many ETL tools have transforms in the toolkit that allow you to do some of this, and they use various techniques. You have to be aware of the situation and what technique would work best because some of the techniques that I'm about to list off here are expensive in terms of processing time, and some are relatively straightforward. So you may have indicators on the row, as I mentioned, with like time stamping or version numbers. That's a very easy way to determine if data has changed. If you have access to the database, you can create triggers on tables, for example, and the triggers would record when this data has changed, and so you can augment the transactional system with the help of triggers. Be careful. People don't like for added stuff to be added to their transactional systems that could potentially degrade the performance. Remember, every time a trigger is fired, you are impacting that database server, and maybe there's no room for impact, and so maybe you can't use that technique, even if you have access to the database itself. You can scan the logs. That's one way that you can determine what has changed by with log scanners. Or you can compare, basically compare your source and your target for anything that has changed. Very expensive way to do it, but sometimes a last resort and a mechanism that you could use. There are other techniques. I just wanted to kind of introduce you to the concept of change data capture. All right, so just went through like the process and some of the bits and pieces, but there are things that we need to worry about when we're developing our ETL architecture, and I just wanted to lay out a couple of these things. I did not intend to cover these in this particular session, but maybe we can in future sessions. But there's things that you have to be concerned with. Scheduler automation, you want the ETL job to be scheduled and to maybe be based on events and things like that. You want to make sure that you have exception handling. Something goes wrong in your ETL process, you want to record the fact that something went wrong and let something or somebody know about it. There's issues with data quality. You want to have the ability in your architecture to recover and restart. If you are running an ETL process that takes hours to complete and something goes wrong just before it was about to finish, do you necessarily want to restart that entire process? Or did you build into your architecture the ability to restart from a point in time of failure? This is very critical. It's something that you have to architect into your solution so that you don't have to start the ETL job from scratch. You can go maybe deal with the issue that caused it to stop and then restart the ETL process, and it'll start up from where it left off. So that's a very good thing to do. Maybe it's not such a big concern in simple ETL processes, which take minutes to run. You can just rerun the whole thing. But it's a good practice or a good technique to introduce into most of your ETL jobs. You also have to have plans for backup and restoring, metadata plans, and security plans. These are things that are concerns of the ETL architecture that we must address as we're building these things. I don't get asked this question much anymore, but I used to get this question quite a bit. It's, hey, why do I need an ETL tool? Why don't I just, I'm a skilled Java or .NET developer. Why can't I just write this stuff myself? And well, obviously, yes, you could write this stuff yourself, but you should use an ETL tool. And it's the equivalent, and these two pictures, if you had to drill some holes, or would you use a hand drill or would you go get a power drill? An automated tool that makes that job a lot easier and faster. You certainly would use the better tool. There's just no fun in working that hard. So there's a lot of benefits to an ETL tool. One of the things that an ETL tool does give you is it gives you a visual flow and automatic documentation of your ETL process. It's basically a tool designed for dealing with ETL in the data warehouse. So all the neat little features that you can think of are part of that platform, part of that ETL tool. Things like error handling and transforms to deal with slowly changing dimensions and transforms for change data capture. You'd be writing all that from scratch. Let me just give you talk about error handling for a minute. An ETL tool, you focus and worry about defining your ETL job. The ETL tool worries about letting you know if something went wrong. It's part of the infrastructure that's built in there, and that error trapping. If you were to write it by hand, you would be responsible for writing that error trapping as well as the moving the data components of all this. You can see how this starts building up quickly, the amount of work that you have to do. ETL tools keep track of data lineage. There's data cleansing rules. There's all kinds of tools in that toolkit that are going to make your life easier. And sure, one can argue that you can go ahead and you can do hand coding. It's more flexible. I don't have to pay the licensing of an ETL tool. I can pick whatever language I like. And these are all true statements. But all I have to say to you, if you want to do this by hand, is good luck to you, and good luck catching up with all the out-of-the-box features that come with an ETL tool. If you've got nothing but time on your hands, it'll be a fun project to work on for quite a long time. So my recommendation to you is don't do it. Go get an ETL tool. Got a couple of do's and don'ts for you. Oh, there it is. Yes, do use an ETL tool. Do plan, design, and map before you get started. Very important. I've stressed this in some of the other presentations. The more work you do up front for design, the better off you are going to be. Make sure that you have contingency plans and contingency budget, because you will need them. There is no such thing as a perfectly smooth ETL project. You will discover things that you didn't know were lurking underneath the covers. Make sure that you understand the ETL process before you get started. It's not just moving data. There's a whole series of things that you have to worry about, and I'm going to show you some places where you can do a little bit of research on your own. And also, it's important to know your ETL tool. I don't care what ETL tool you use. There's many very good ETL tools out there. There's many open source ETL tools out there, but be careful. You get what you pay for sometimes. and spending a little extra money on one tool might be worth the expense. And also make sure that you use data profiling tools. Many of the ETL tools come with data profiling capabilities. It basically gives you a quick way to get a snapshot view of what's the condition of my data, what kind of outliers do I have, how many null values are floating out there waiting for me. And many of the tools let you drill into some of the things that it finds so you can find out where that data actually is causing trouble. A couple of don'ts I have for you. Don't assume it will be easy. It may be fun, but it certainly is not easy. Don't assume that there will not be any issues. Don't try to fix data issues in your ETL. Fix them at the source. That's not to say that you can't do some cleansing of data, but don't mess with making data right in the ETL so that then it doesn't match the source system. Identify it in your ETL, maybe log it, and go have it taken care of either manually or through an automated process in your source system. Don't hand code your ETL, and please, oh please, don't abuse the SQL transforms. ETL tools have these functions called transforms. One of the functions is the SQL transform. Don't be tempted into writing cool SQL, sticking it into the SQL transform, and then your ETL tool is nothing but a scheduler for SQL. There's a time and place to use the SQL transform. It's not the silver bullet that fixes everything. All right, and wow, 2:51. I'm going to actually end on time this time. So today's presentation was about introducing you to a variety of concepts around ETL, and you can see that even in just this presentation, there are many, many things that we can dive more deeply into. I was thinking about some of the potential topics to dive into, things like techniques for loading dimensions or techniques for loading facts. Maybe talk about some of those change data capture techniques would be another approach. Dealing with mainframes. They're still out there, and they're still part of sources that we have to contend with. Maybe a topic on data profiling. In any case, these are some of the things that I came up with. What I would love for you to do over the folks that are on over the next week or so, if you come up with any topics or anything that you want to add to this list, please, oh please, make sure that you send them to Lori Blanford. Pardon me, I'm losing my voice. It's a voice change. That's what's going on here now. I'm hitting puberty.
It's your winter to spring voice.
It's my winter to spring voice. And Lori will collate all that, and she'll tell me what topics win or what topics showed up the most, and I can take those into consideration when determining what the next presentation will be. So I have some recommended reading for you. If you are going to embark on an ETL project, or if you already are in one, or if you're an ETL developer and you have not read this book yet, the Data Warehouse ETL Toolkit, great book to give you a very good sense of the science or the method around the ETL development and things that you have to be concerned with. So certainly it's a recommended read. There's also the Kimball Group website. There's our website for the previous presentations. So these are a variety of places that you can go to and find out a little bit more. And remember, Google is your friend. You can find lots of this information using Google as well. You just have to know what you're looking for. All right. So this presentation, as the other ones, will be made available online. Those who attended this presentation can get the information from our portal, from our website. And spring has almost arrived in Chicago. It's still, winter does not want to seem to go away, but it is a little bit warmer today. So hopefully the next time I talk to you, it'll be nice, sunny, warm weather, and I certainly appreciate all your attendance. And if there were any questions that were submitted there, I will review them, and we'll send out the responses to those questions at a later time. Thanks, everyone, so much, and have a great rest of the day and a great rest